So we're going to talk about lesson 6-6, so chapter 6, lesson 6, and we're going to talk about a system of linear inequalities. I need to change my calendar. We are at 3:2 today. So I'll give you a quick definition of what is a system of linear inequalities. And basically, if you went back and looked at your definition of system of linear equations, we're basically talking about the same thing, except for we would substitute in the word inequality for the word equation. So it is a set of two or more inequalities. So we're going to have greater than, less than, greater than or equal to, less than or equal to, written in the same two variables. For most purposes, you're going to see x's and y's. I don't like the way I wrote that. Never ask why. Just do or die. Okay. So here's what's interesting. When we were doing the system of linear equations, what was our answer? I graphed two lines.
A number?
Okay. Wasn't? What's a solution? What do you mean by solution? Okay. What would it be? What is?
Consistent.
What is it that satisfies both?
Consistent and independent.
Nope. It's a point. An ordered pair. That was the solution when it was a system of equations. But now that it's a system of inequalities, remember what ends up changing from graphing an equation to graphing an inequality. That inequality dictates two key things about my graph. It dictates whether my line is solid or dashed, and it dictates whether I shade above or below. What becomes challenging now is now I have two equations on the same coordinate plane, and I have to pay attention to, do I solid or dashed, above or below? My solution is going to be where the graphs overlap. So it's not a single answer, it's a wedge of answers. So basically, this system of linear inequalities is going to take your coordinate plane and break it into four sections. One of those sections will be the solution. If you're not accurate with how you graph, you don't pre-test where to shade before you shade, and you just, I'm going to trust that I'm doing this right, chances are you're going to shade incorrectly and you're going to get double shading regardless if you shade correctly or incorrectly, but it may not be the right double shading. So you have to be extraordinarily accurate. Now, some of the issues we came across with inequalities, what was the big thing you had to watch out for when solving an inequality?
If you were dividing or multiplying by a negative, it flips the inequality.
Yeah, if you did not pay attention to that multiplying or dividing by a negative and you didn't flip your inequality, well, now you've just changed whether you shade above or below. And that, again, is now going to take you out of getting the right answer. So this is a lot of detail that you need to pay attention to. So, number one thing that we're going to do, well, let's talk about the solution first, and then we'll talk about strategy. So, solution for a system of inequalities, we'll just take out the word linear. And that's going to be the intersection. Oops, sorry. Get out of that. The intersection. The book uses the word overlap. Of the graphs of the inequalities. Okay. And it is, so it's an infinite number of solutions. But that's not what you get to write. You're just going to color. So it's going to be a really good idea for you guys to have colored pencils to work on your homework tonight to do the overlapping. And it always makes me happy when my math is colorful. So I enjoy when I get to do that. So we're going to be graphing linear inequalities. So thinking back that graphing a linear inequality is the same thing pretty much up until a certain point of graphing a linear equation. What's the best way to set up my equations or my inequalities in order to graph them? You got to go slope-intercept form. Now, more so than equations. Equations, you actually had an option. You could leave it in standard form. You could figure out the x-intercept. You could figure out the y-intercept. Graph that way. Unfortunately, with linear inequalities, if your equation's not in slope-intercept form, you're not really sure what your inequality is. So that is a must for our how-tos. First and foremost, if it's not already done for you, rewrite each inequality into slope-intercept form. Now, I can tell you some things I saw in your quiz that cannot get repeated. Not verbally, but by you. When you write it in this fashion, now again, we're going to have an inequality instead of an equal sign. What does the M mean? Most of you got this down, okay? That's your slope. And we're going to be making sure that slope gives us a rise number and a run number because we need two coordinates in order to find a new point. It's the B that worried me more than anything when I saw this happening on your test, because this should never happen. What does the B represent? The y-intercept. Even though you guys can verbalize that, many of you graphed it on the x-axis. To be a y-intercept, it needs to intercept or intersect the y-axis. So that y-intercept is graphed on the y-axis. Okay, so you got to understand what the words mean. Because again, even after we've done lots of graphing and whatnot, I still saw people graphing the y-intercept on the x-axis. Okay? So rewrite each inequality into slope-intercept form. Y equals mx plus b, where m is the slope, which we're going to write as a fraction, as rise over run number, so we can find a new point after we graph the y-intercept on the y-axis. Next. Graph one inequality at a time. Okay. And we have multiple combinations of what we can do for what our graph physically looks like. We can do a dashed with above, or we can do a dashed with below. We can do a solid with above, or we can do a solid with below. So it all depends upon our inequality. So let's just review that briefly. If my inequality is greater than, what does my line look like, and where do I shade? This is dashed, and what's the other one? Above. So greater than means above. So physically above. And then if it's less than, dashed, below. Greater than or equal to? Solid, above. And less than or equal to? Solid, below. Okay. Now, we had talked about when we were just doing a single linear inequality, something that you needed to do to ensure that you shaded the right direction. So what did we tell you to do? You don't have a solution. What do we say? Okay. We needed to test, right? We needed to test a point. We had, so before shading, test a point. Now, you can do it one of two ways. I'm going to demonstrate it one way. You have multiple options, so I'll explain the other ways. I'm not going to write it down, though. When you test, you can already kind of have in your mind, oh, I'm going to be shading above based on the inequality. Pick a point that's in the above, plug it back into your inequality, and see if you get something that's true. If you get something that's true, then that concurs, yes, I'm going to shade above. If you plug in that point and you get something that's false, chances are you're supposed to shade below. Now, the issue comes that you guys could make calculation errors. So instead of choosing a point that's there, I'm going to ask you to choose the point 0, 0. But instead of choose it because it's in the region you're shading, I just want you to choose it and test it. So if you put in 0, 0, so if you get something that's true, so by true, it could be something like this. 5 is greater than 2. That's true. What that says is shade where 0, 0 is. So you're going to shade the half of your graph where 0, 0 is. Okay? If you put in 0, 0 and you get something that is false, so 5 is less than 8. Greater than. 5 is greater than 8, which that's not the case. You're going to shade the half where 0, 0 is not. So we're going to make 0, 0 be our confirmation. It's easy to calculate with zeros. We tend not to make mistakes with zeros, so that's all well and good. Okay, so then we're going to look for the doubly shaded region. I'll just write that here. The doubly shaded region now what's interesting is that it's bordered by parts of our boundary lines, and that's part of the solution as well. So double shaded region plus the portions of the boundary lines that flank it is the solution. So in order to make it stand out in a third color, I would highlight that region, or highlight it, physically highlight it. Jenny, sorry.
The boundary lines are only if it's a solid.
Well, you still highlight them because the dash just means the points on that part of the boundary line are not solutions. Solid would mean the points are, but they are part of the solution. The lines are part of it. Okay, that doesn't mean that every single point on those lines are going to be a solution, but it starts from here and goes to here. Doesn't include these, but it may include the others. It may include both. It may include neither of the boundary line points, but it's telling you where your wedge begins and ends. Okay? All right, so let's get one done. Let's see what it looks like. So the answer, basically all you can do is solve the system by graphing. There is no other option here, folks, since there's an infinite number of solutions.
So is there parallel?
Excuse me? Just because they're parallel doesn't mean that there wouldn't be a solution. It depends all upon the inequality sign. There could still, even if they're parallel, that may be what's in between. The parallel could be, it goes both the same direction, and there's a double overlap. It's all about where do you have a double overlap, okay? So let's do we'll give you two equations that are already written in slope-intercept form. So we have y is greater than negative 2x plus 1, y is less than or equal to x plus 3. So first thing we do is identify our key pieces, and we've got 3 that we identify. First, what's the slope in this first one? Negative 2, and we're going to create that fraction because we need a rise number and a run number. So the negative only gets on one spot, and I'm going to put it in my numerator. And what's the y-intercept? Not just 1, and we would graph it as the point 0, 1. But we're not done. I also want to investigate the inequality. So what is greater than? Tell me that the physical line is going to look like. Dashed. And where am I going to shade? So before I even do anything else, I'm going to test 0, 0. So is 0 greater than negative 2 times 0 plus 1? Is 0 greater than 1? False. So that says do not shade where 0, 0 is. I'm getting all my prep work done out of the way before I actually physically graph. Okay, let's do the other guy. Okay, what is the slope? 1 over 1. And the y-intercept? 3. Less than or equal to what kind of line? Solid below. We're going to test 0, 0. Oops, sorry. And is 0 less than or equal to 3? That's true. So what that says is you're going to shade where 0, 0 is. Okay? So let's get our graph paper out. And let's get my graphing done. Now, there's a couple thoughts about this, and some people actually erase all the stuff that doesn't count. I think that's not really a great idea, but because it's just really messy. So you have to learn to work within what you have. 1, 2. So we're negative 2, 2, 2, 4, x-axis, y-axis, blue line. We go to where the y-intercept is 1. I do need to add a couple more points down here on the negative. There we go. We're going to rise down 2 and to the right 1. We're going to do a dashed line. And to graph above it, we're going to make sure that 0, 0 is not part of the graph. So I'm going to shade above like this. Okay. Now I do my green. I go to where the y-intercept is 3. I rise up 1 and to the right 1. It's a solid line. Okay. And then I'm going to have below, and it says you better shade where 0, 0 is. So I would be shading like this.
Wait, so the colors are just coming next?
That's called overlap. So what's my solution? I'm going to highlight it in a new color. It starts here at the intersection point. It's solid at the top of it. It's dashed at the bottom. And it's everything in between. Okay? Now, that's the double shaded region. It was blue and green, right? That's what we're looking for, the overlap. Now, how could you confirm that you did get the ultimate right answer? Brandon?
We can confirm by looking at the test right there, the 0, 0, and see if it...
But beyond.
Beyond that?
Mm-hmm.
Just taking a random point and then plugging it into the equation.
Exactly. So what we do is we find a point in that double shaded region. What point would you like to test?
2, 2.
Okay, we'll do 2, 2. And it better be true for both of them. So is 2 greater than negative 2 times 2 plus 1? Is 2 greater than negative 4 plus 1? Is 2 greater than negative 3? Yes, so it's true for the left. Now let's try the right. Is 2 less than or equal to 2 plus 3? Is 2 less than or equal to 5? True. This point right there, that 2, 2, is true. So what that says is, yes, we did shade it correctly, and that's how I do this.
Wait, what'd you get? The second check?
Randomly selected from the region that we doubly shaded. Okay? All right, let's do one more real quick. This one, you're going to have to work a little bit more. So let's have x plus y is greater than 2, and negative 4x plus 2y is less than 8. So the problem here is, what's the problem? Not in slope-intercept form. So we're going to do that first, get the y's alone. So we get y is greater than negative x plus 2. This one we're going to add 4x to both sides. That gives us 2y is less than 4x plus 8. We're going to divide everything by 2. And we get y is less than 2x plus 4. Now we identify our information. Slope on the first one is negative 1 over 1. And for the y-intercept, it's 2. Greater than tells me two things. Dashed and above. I'm going to test 0, 0 quickly. And I'm going to go back to the original equation. Is 0 plus 0 greater than 2? Is 0 greater than 2? Okay. So because that's false, what that's going to tell me is that you better not shade where 0, 0 is. Okay. Let's do the other one. What is the the slope, I'm sorry? 2 over 1. The y-intercept is 4. Less than, what kind of line? Dashed. Below. Let's test 0, 0. So is, and I always go back to the original, negative 4 times 0 plus 2 times 0, is that less than 8? So we get, is 0 less than 8? Yes, that's true. So what that says is you will shade 0, 0. Okay? All right, so my graph. Gonna look like this. 1, 2, 3, 4, 5, 6. Here's my y, here's my x. 2, 3, 4. So on the blue one, we find where y is 2. We rise down 1 and to the right 1. Dashed. We said above, and we said do not color in 0, 0. So that concurs that I'm shading away from where 0, 0 would be. Green. Find where y is 4. Oops, I didn't put my numbers in, did I? Sorry. 2, 4, 6. And then I'm going to rise up 2 and to the right 1. It's going to be dashed. And we're going to shade below, which says you should cover where 0, 0 is. So we concur. Oh, strange. Look at that. I got the same sort of side as I did on the last one. That was random. So I highlight what my answer is. Here's where they intersect. So that's the starting. I was dashed at the top of my solution. I was dashed at the bottom of my solution. And then everything in between those dashed lines was my solution. Okay. Now again, you can use a highlighter, you can use a third color, whatever you want to do. Okay.